All right, welcome to our second lesson for Unit 3. So we talked about specialists and generalists last lesson, and now we're going to talk about case-selected and R-selected species. So another way to characterize different species. So learning goals that you'll be able to describe the difference between case-selected and R-selected species. The AP learning objective, identify key differences between K and R-selected species. So you can pause to read this. I'm not going to read them all word for word, but these are the essential knowledge pieces that College Board wants you to know, okay? So when we talk about K-selected and R-selected species, we're talking about reproduction kind of methods or priorities, or it'll make sense. But the one way to kind of differentiate is one is kind of quality versus quantity, which is a weird way to talk about offspring, but that's how it works for this. So for K-selected species, focus is quality. So they have few offspring, like not very many, but there's a lot of parental care to protect them. So they are putting effort into making high quality babies that are going to be able to survive. So they generally have few reproductive events, fewer than R strategists. So they're not having babies as frequently. So examples are most mammals and birds. Not all, but most. They tend to live longer. They have a long time to sexual maturity, meaning like they're not immediately able to have babies. It takes some years for them to be able to reproduce. That means that they have a low biotic potential, which means a slow population growth rate. And they're more likely to be disrupted by environmental change or invasive species. Think about what type of species that relates to with our last lesson, talking about specialists versus generalists. Remember, it's a spectrum, but there are some similarities. R-selected is going to focus on quantity, just lots of babies, lots of offspring, little to no parental care. You're just pumping a bunch out, hoping a few of them survive. They may reproduce only once, but generally reproduce many times throughout their lifespan. And examples are insects, fish, and plants. And those species that only reproduce once, they're having like a ton of babies and their lifespan is really short. Like a lot of insects don't live that long, and so they pump out a lot of babies in one go. So shorter lifespan, they're quick to sexual maturity, meaning they're able to have young really quickly. High biotic potential, which means a high population growth rate, and they are more likely to be invasive and better suited for rapidly changing environmental conditions. So this picture right here is of a sunflower. These are all sunflower seeds. So this is one flower with like hundreds of seeds. This would be quantity over quality. There's no parental care going into this. It's just a lot of seeds that will turn into little sunflower babies. So let's compare habitats and populations with the two. So K-selected tend to live in habitats with higher competition for resources. Populations that reach carrying capacity is signified as K. We will get into that in a later lesson, but K is carrying capacity. And K-selected species tend to remain at a stable size near carrying capacity, which is why they are called K-selected or K-strategists, as they're living at carrying capacity. R-selected tend to live in habitats with lower competition for resources. Populations are more likely to fluctuate above and below carrying capacity. The population will get really, really huge and then die off. And they get really, really huge and then die off. They don't really hover around a specific number. And R is the variable used to represent maximum reproductive rate in ecology, hence R selection or R strategist. Here's a table kind of comparing. So K strategists tend to live longer, take a long time to be reproductive. They don't have a lot of babies. They have larger offspring, and their population dynamics are fairly stable. Just like our specialists versus our generalists, it's a spectrum. So like human beings, chimpanzees, we are strong K strategists. Lots of the large felines, so pumas, lions, they are on the K strategist side. Hares are in the middle. They have a lot of babies every year, which kind of like, but they do provide parental care. Frogs are more on the R side, but they do provide some parental care. Fish, oysters, they are way on the R side, as well as plants, most plants. So this is what I mean by a spectrum. So remember, hares and frogs are kind of close together. Frogs have more babies a year than hares do, but hares are mammals, so they do provide at least some strong parental care with that. The moms will provide milk for the babies, and they do live together for a time. Frogs don't do a ton once their offspring are frogs, but some frogs kind of carry the tadpoles along on their backs. All right, when it comes to invasiveness and disturbances, K-selected species have a low biotic potential, which means low reproductive rate, and it's hard for a population to recover after a disturbance. And high parental care means the death of the parent equals the death of the offspring. That doesn't mean if a parent dies, then the offspring automatically dies, but that means if this big polar bear who's still taking care of the little baby polar bear, this big polar bear passes, it is way more likely that its baby will as well. And invasives, which usually outcompete for resources with high biotic potential and rapid population growth. They're able to outcompete for resources because there's usually so many of them. And K-selected are less likely to adapt and more likely to go extinct, just like our specialists, because there's a lot of over. All right, R-selected, they have a higher biotic potential, higher reproductive rate, more rapid population recovery after disturbance. Low parental care means the death of the parent doesn't impact offspring. If that sunflower sheds all its seeds and then dies, that does not impact how well the seeds will sprout. They're not as impacted by invasive species since their populations grow quickly. They're more likely to be the invasive. This is a spotted lantern fly. They are super, super invasive. If you see them, please kill them. They have a larger population and faster generation time, which means they have a higher chance of adaptation and a lower chance of extinction. If you're constantly reproducing, then your population can more quickly kind of change to fit whatever the environmental pressures are versus an organism that only reproduces maybe once a year. It's going to take a long time for that species to change. So your practice FRQ for this guy is to identify one characteristic of an R-selected species that could increase the likelihood of the R-selected species becoming a more successful invasive species than K-selected species. All right. Let me know if you have any questions, and I will see you in the next one.